About 94.1 million barrels of oil are dissipated every day in the year 2021. An even bigger problem is the improper disposal of oil waste. It is either flushed in the sink, thrown in canals, placed in trash bins, or reused for further frying. Such practices do not only degrade the environment but also bring threats to the community, causing clogged drainage and damage to human health and biodiversity. It is without a doubt that oil is essential to the community. However, a large consumption of oil in different industries, particularly in the food industry, is associated with mass production of cooking oil waste. A pleasant day to each one of you. Together with my co-researchers Team BORON, we are here to present our research proposal entitled Utilization of Used Cooking Oil in Soap Production. Globally, there are several types of oil produced and introduced in the market. Oils are mainly composed of long chains of hydrocarbons and consist of triacylglycerols, making them hydrophobic and lipophilic. The key difference between edible oils made from plant and animal sources is the saturation of their fatty acids. It is said to be saturated when its carbon atoms are bonded to the maximum amount of hydrogen atoms that it can hold. Plant-based oils are liquid at room temperature and have more unsaturated hydrocarbons. Canola oil is composed mainly of oleic acid, a monounsaturated fatty acid. Meanwhile, animal-based oils or fats are solid at room temperature and are mainly composed of saturated hydrocarbons. Palmitic acid, a saturated fatty acid, is found in animal-based oils.
Despite its various uses in several industries, oil still has more other uses, such as in soap production. Saponification is a reaction that proceeds when an alkali base is combined with oil to form soap. During this process, esters in oil exposed to hydroxide undergo hydrolysis to yield carboxylic acids. Afterwards, the carboxylic acids are deprotonated to produce carboxylates. This carboxylate is then neutralized until carboxylic acid salts precipitate out of the solution. It can yield a solid or liquid soap, depending on the type of base used. If oil is treated with sodium hydroxide, it produces sodium salt of carboxylic acid, and the type of soap manufactured is a solid bar soap. On the contrary, if oil is mixed with potassium hydroxide, it forms a potassium salt of carboxylic acid, and the type of soap obtained is a liquid soap. To address this pressing issue regarding oil waste, many environmental advocates and scientists are seeking schemes to repurpose waste cooking oil. The idea of utilizing used cooking oil, a plant-based oil, for soap production arises from this matter.
The wasted cooking oil will undergo decontamination physically and chemically. Filtering is the first step, which is the sample is filtered 3 times by filter cloths. The solid particles were filtered from the solution. Degumming, a process that removes phospholipids from crude oils. The process is done by adding water to the oil and then heating it. The gums are then separated from the oil by centrifugation or filtration. Next is the refining, used to manufacture of pure soaps to refine the oil by treating it with alkali to remove free fatty acids. Next, from the purification or the decontamination of oils is the deodorizing. A superheated vapor stream passes through the oil. When the refined oils or fats is mixed with NaOH or KOH in the reaction chamber, sodium hydroxide or potassium hydroxide granules are not used here, and only aqueous solutions are used. First, sodium hydroxide is taken and dissolved in water. When triglycerides in fat or oil react with aqueous NaOH or KOH, they are converted into soap and glycerol. This is called the alkaline hydrolysis of esters. Mixtures obtained by removing glycerine further contains impurities such as H2O, NaCl, and NaOH. Therefore, in this step, the resulting mixture is centrifuged. The mixture is further rotated with the impurities in a high-speed perforated vessel. It removes most of the water and salt that are the main product. But the final soap product contains about 0.5% NaCl weight by weight. There may be further unreacted sodium hydroxide, and sodium hydroxide can cause etching on the skin and damage the delicate tissues of the eye. Therefore, any remaining sodium hydroxide should be removed by neutralizing existing caustic soda by adding a weak acid such as citric acid. In addition to citric acid, phosphoric acid can also be used as a weak acid for this process. The entire batch of the soap mixture can either be poured into one mold to be caught up after it solidifies, or individual molds can be used. The soap is left to cool and finish the saponification process.
The general objective that our research aims is to determine the effectiveness of using used cooking oil for soap production. Specifically, our research objectives are as follows. First is to examine the physico-chemical properties of used and unused oil as soap. Second is to evaluate the quality of soap made from used oil. Lastly is to inspect the environmental, health, and safety considerations of using used oil for soap production.
For the methodology section, we used a flowchart that are easy to understand diagrams that show the steps of a process fit together and to evaluate the overall efficiency of our study. Having a goal of producing low-cost and environmentally friendly soaps, soap making was proposed. To utilize used cooking oil, liquid soap, and bar soap were developed. In soap making, it is not possible to remove dirt, especially oil and grease, by just using water. That is why we use the decontamination process and saponification, which is the modern technique to form solid soap that uses plant oils and or animal fat and sodium hydroxide to form solid bars or potassium hydroxide to form liquid soap. Under it, we have the separation, purification, and curing that are necessary for the saponification process. The advantage of these processes was that it allows for purification of the fatty acids and thus produces a higher quality soap in soap making. Liquid soaps and bar soaps are then obtained and their properties were analyzed. After the analysis, comparison between liquid soaps and bar soaps made from used oil and unused oil was done to search for similarity and variance among units of analysis as well as to involve the description and explanation of similarities and differences of conditions or outcomes.
The overview of analyzation techniques for determining properties of soap. First, the pH level affects the soap's cleansing properties, mildness, and skin compatibility. Soaps with higher pH level tends to be harsher on skin, while lower pH levels are gentler. pH level can be determined by pH meter. Second, excess moisture in the used oil can lead to several issues, including separation of soap mixture, reduced soap quality, and potential spoilage. Controlling and knowing the moisture content helps ensure the production of consistent and high-quality soap. Analytical balance, model ALS250-4A can help determining the moisture content. Third, alkalinity is an important parameter as it determines the soap's cleaning ability and its potential to cause irritation to the skin. Excessive alkalinity can lead to harsh soaps that may cause skin dryness and irritation. And titrating excess acid using standard sodium hydroxide solution can measure the alkalinity of the solution. Fourth, knowing the hardness and adhesion of the water used in the process is significant, as hard water can affect the soap's performance. And with the use of P-5 probe, we can identify the hardness and adhesion of the samples. And lastly, the total fat content directly influences the soap's cleansing ability, lather formation, and overall quality. Understanding the fat content helps ensure that the soap has the right balance of ingredients for effective cleaning and a pleasant feel on the skin. Dissolving the sample in ethanol and measuring the insoluble matter in alcohol can find the total fat content of the soap.
Moving forward at the tail end of our discussion, Here is a Gantt chart showing the schedule of the team for the entire duration of the study. It contains all the necessary steps and activities that must be done in order to accomplish this research study. As shown, there are 3 key steps, namely acquisition of reagents, laboratory work, and research study completion. The first phase of the plan is the acquisition of reagents. On the first day, the researchers submitted a reservation slip to the PUP College of Science laboratory storage to secure the chemicals needed for the conduct of the study, like NaOH and KOH, as well as some equipment such as filter papers, glass funnel, separatory funnel, beakers, hot plate, pH meter, etc. On the same day, the researchers also collected unused cooking oil from the markets. Meanwhile, for 3 days, the researchers sourced used cooking oil from either households or restaurants.
After gathering all the necessary materials, the researchers proceeded on doing laboratory work. Only a day was allotted to decontaminate used oil, analyze its properties and compare it to unused oil, and saponify both used and unused oils to produce liquid and bar soaps. Since liquid soaps do not need curing, it was already analyzed a day after saponification. 3 days were allotted to analyze the properties of liquid soap made from used and unused oil, and their properties were compared on the 3rd day. The produced bar soaps were given 4 weeks to cure before analyzing its properties. Similar to liquid soaps, 3 days were allotted to analyze the properties of bar soap made from used and unused oil, and their properties were compared on the 3rd day. Now that the researchers have collected the data, it is time to write the research study. The allotted time to process, check, and verify the data is 3 days, and the remaining days of the week until the 7th week was utilized to write the research study. Overall, it took the researchers 7 weeks to complete the study.
This concludes our proposal about utilization of used cooking oil for soap production. Thank you and God bless.